Hello there, let's have some fun in this video. Here we're going to estimate the mass of an entire world in Minecraft. Let's go ahead and get started here by thinking about the numbers involved. So in Minecraft, a block is defined to be a cubic meter, which is really nice because that means I can write everything going forward in terms of SI units. Now, we can effectively think of the world of Minecraft as a giant slab. And the length and the width of this slab are each approximately 6 times 10 to the 7th meters according to the Minecraft wiki. Now, for the thickness of this slab, I'm going to consider the latest version of Minecraft that I've played up to, 1.19.4, in which the Y level of bedrock is down at y equals minus 64, and sea level is at y equals 64, giving us a thickness of 128 meters. And we're going to assume that deviations from our sea level due to hills and valleys are equally likely. Okay, but roughly speaking, we can treat the thickness of this slab as a uniform 128 meters. Now, from our perspective as the player, this slab is so massive that we can treat it as infinitely wide. So if I put my XY plane on the surface of this slab, we can imagine the corners of the plane stretching from plus infinity to minus infinity. And what's really nice about making this approximation is it adds a bunch of symmetries to the problem. So first, if I draw this vertical z-axis in, we're now going to have continuous rotational symmetry about the z-axis. Right, for any rotation around that z-axis, everything's going to look exactly the same because your plane is spreading out infinitely anyways. And likewise, we're going to have a translation symmetry in the XY plane. No matter how I move around in the XY plane, there's still going to be infinite amounts of slab stretching out in all directions around me. Right, and so the gravitational field produced by this slab is also going to have to follow these two symmetries. So when you put these two together, you're going to find that the field must be uniform in the X and Y directions, and it's going to have to point vertically. Which should be pretty intuitive, right? We know we're going to get attracted towards this plane. Right, so this infinite slab approximation added a bunch of symmetries to our system, which then made our gravitational field very, very simple. Now we're going to have to take some creative liberty here and assume that the Minecraft world obeys this kind of basic physics here. Right, because the reality is if you go through to the other end of your Minecraft world, you break through the bedrock, of course you know that you're just going to keep falling down, you're not going to be attracted back to this slab here. Right, and furthermore, if you looked at the gravitational field within the slab, right, it has to actually turn around, right, in order for those field vectors to flip. And so around halfway through your Minecraft world, you would expect there to be zero gravitational force, which of course is also not true. But again, for the sake of creative liberty, let's assume that our Minecraft world does indeed function like a perfectly normal, physical, uniform slab. If we make this assumption though, we can use information about Minecraft's gravitational field, i.e. the gravitational acceleration on Minecraft, in order to come up with an expression for the mass density of this slab. How exactly can we do that? By using Gauss's law. Let's go ahead and imagine a cylindrical surface which passes through the infinite slab. The caps at the top and the bottom of this cylinder have an area which I'll call A. This surface that I've drawn here is referred to as a Gaussian pillbox. Now Gauss's law tells us that for an arbitrary closed surface, right, like this Gaussian pillbox that we have here, the total gravitational flux through that surface, which is effectively the net inward or outward push from our gravitational field on that surface, is going to be equal to minus 4 pi times our gravitational constant times the mass enclosed by that surface. Now, for this relatively simple pillbox here, it's actually really easy to compute the flux. Let's go ahead and look at one of those caps. If I look at the top cap here, what I have is a bunch of gravitational field vectors pushing directly onto that cap. Each field vector is going to be pushing directly on, aka it's going to be perpendicular to the surface of my cap. So in this case, the expression for that total push through is going to be really simple. We get the flux through our cap simply by taking our gravitational field, whatever that magnitude is, times the total area of our cap. And then we put a minus sign by convention. Pushes into a surface are considered negative, pushes out against a surface are considered positive, right? And our field here is clearly pushing into our Gaussian pillbox. Now, because our field lines are parallel to the tube part of our cylinder, there's not any push in or push out there. So it's purely in the caps where we're getting our flux. So because we have two caps, our total gravitational flux is just going to be minus 2GA. Next, let's go ahead and determine the mass enclosed by our Gaussian pillbox. We can write out the mass enclosed by my Gaussian pillbox by taking the mass density of my slab times the volume of slab that's inside of the pillbox, right? And if I call the thickness of my slab T, then we can immediately see that the volume of this purple region of slab inside of my Gaussian pillbox is going to be equal to A times T. Nice, so now let's go ahead and plug in our expressions for M enclosed and phi sub g into Gauss's law. Look at those A terms, they're going to cancel out. And so we can get out this really nice expression for the mass density of our slab purely using the constant gravitational field strength of the slab and the thickness of the slab. Right, so let's go ahead and remember what terms we're going to plug into for this Minecraft world. Remember, the thickness of the slab is 128 meters. Remember, big G is just a constant, our universal gravitation constant. Let me also remind us that when we're discussing gravity, this G, this gravitational field strength, is identical to the gravitational acceleration that an object will experience in that field. That's something really special about gravity. It's not true for example, electric fields. Okay, but the point is, as long as we know the gravitational acceleration due to our slab, then we can just plug that guy in for G. And according to the Minecraft wiki, well, Minecraft's kind of weird because it doesn't just have one gravitational acceleration. Different objects accelerate differently. So I'm just gonna go ahead and use the gravitational acceleration that we as players experience. Right, and so if we plug all of these numbers in, we can find that on average the mass density of our Minecraft world is 5.97 times 10 to the 8th kilograms per cubic meter. Wait, hold on a second. That's massive. That's 600 million kilograms per cubic meter. To put that into perspective, a world in Minecraft is approximately 100,000 times more dense than our Earth. So keep that in mind when you've got an inventory full of blocks for just how much weight you're actually carrying. But anyways, let's go ahead and wrap up this question. To get the mass of our entire Minecraft world, we're going to take this average density times the volume of our Minecraft world. And you know, we have all the dimensions, I'm showing them up there, so we plug all those guys in, and we're going to find that our Minecraft world has a mass of 2.75 times 10 to the 26 kilograms. If you enjoyed this video, found it interesting, let me know in the comments and consider subscribing to the channel. I love to hear about people getting on board. But other than that, thank you so much for watching.